Honorable judges, good morning and namaste. Here we are going to demonstrate a simple machine called as LenzAmoblile. This machine, which can be assembled in a village school by the high school students, and it is mainly used to conduct various experiments pertaining to standard 9th and 10th. The machine is based on Lenz's law of electromagnetism and Newton's laws of motion. This will help us to control the motion of small objects and perform various experiments. Now, as you can see here, there is a copper tube, right? And then, as you can see here, that there is a copper tube and there is a magnet. Okay, this is a very powerful magnet, and then this magnet is coming through this arrangement. Consider this as a pulley, and then a cotton thread is running through, and I have used a carom board here because I want a smooth surface, and then you can see a trolley here. The trolley basically is the striker of this carom board, and on which it can be loaded basically. And right now I have overloaded it. Due to friction, it is staying static. Now, when I take this magnet and insert it into another tube, which is just a plastic tube. Okay, it is just a plastic tube, and now what we see here is that the magnet has got some mass, and due to gravity, the force acting is m into g, and therefore the moment I remove the overload on this trolley, this magnet starts descending due to gravitational force, and you will observe that the trolley moves quite fast. And with that speed with which it is moving, it is we are unable to measure the motion, and therefore we are going to make use of the copper rod, and you will see, the velocity of the trolley will be drastically reduced, and it will enable us to take the measurements. Okay, so here we go. I am going to release the extra load on the trolley, and the trolley will begin to move. So I am removing the extra load on the trolley. So you can see that it has moved considerably fast. So I am going to release the extra load on this trolley. You can see that there is a stopwatch which is running, and when I say start, that means the trolley starts moving. When I say stop, it is when the trolley has reached the end point. So that we will come to know approximately what is the duration for which it has moved, and thereby we will be able to calculate the velocity or the speed of the body here. Okay, so start. Stop. So we can find out how many seconds it has consumed before it has stopped. And I'm sure that everybody would have seen that it has moved with considerable speed. Now I will remove the magnet from this plastic tube, and I'm going to insert it into the copper tube. And then let's see, that the velocity is manageable. That is, it will start moving slowly, and the webcam can capture the motion, and with the limitations there, we will be of course able to measure the motion, okay, because it is going slowly. So here I go. I'm taking out the magnet. I'm inserting the magnet in the copper tube and ensuring that it is not touching anything. I'm aligning this, right? It is aligned, and now I will start the stopwatch, and I will remove this extra load so that the trolley can now move. So you can see that the trolley is moving considerably slowly, and well, it has almost taken some 5 seconds to travel a distance of approximately 70 centimeters. Okay, so this is how the system works, and well, this is based on Lenz's law. That is, as the magnet is traveling through the copper tube, according to Lenz's law, it is going to generate, the electromagnetic induction takes place, and because of which it will generate eddy currents, and the direction of the eddy currents in this copper tube is to oppose the motion, it's to oppose the change of the magnetic flux through the copper tube, and thereby it is creating a force which is opposite. That is, if the gravitational force is down, the force due to the magnet is up. So therefore, the motion of the magnet inside is retarded, and that's why we are able to see the trolley going with lesser speed.